Have you ever wondered how some people can survive even after falling from great heights? Well, the answer is physics. To maximize your chances of survival, you need to decrease your speed and decrease your net resultant force. So, you essentially fly to the ground. To learn how to survive a free fall, let's look at a scene from Indiana Jones and the Temple of Doom. Well, falling off a plane in a dinghy might be a good idea, but why did Indiana Jones do this? Would it be better if he would simply follow the plane without the dinghy? Let's find out the answer. Well, as we know, gravity is responsible for anything falling. Many things are possible just because of gravity. But what does it mean? Gravity will attract any body that has mass. This is a simple principle that we know. While falling, our bodies accelerate. In a free fall, which is exactly what is happening here, the bodies will accelerate at a g constant. This g constant is known as acceleration due to gravity. This acceleration due to gravity changes from planet to planet due to the change in planet's mass. So, for Earth, a free-falling body will accelerate at 9.8 meters per second square. On the Moon, this would be 1.6 to 5 meters per second square. The only factor that can change the speed and acceleration of a free-falling body is air resistance. Now, if we plot the motion on a distance versus time graph, it would look something like this. And something like this on a speed versus time graph. The body's speed is increasing at a constant rate. Simple, right? But when we consider the air resistance, the story changes. As the body accelerates, the air resistance also increases, as the object will have to bump into more air particles as it falls. When a body falls, it falls due to its weight. Weight is mass into acceleration due to gravity, and this is measured in newtons. The air resistance is an upward force, which is opposite to the downward force of the weight. The force opposes each other, and the net resultant force is what determines the acceleration of the object. This means that the air resistance and the weight are having a tug of war, and as the speed increases, the air resistance becomes much more stronger. This causes the graph to look something like this. The object's rate of acceleration would gradually decrease until it stops accelerating. After that, its speed would stay the same and not change anymore. The constant speed is known as terminal velocity. Terminal velocity is reached when the downward force exerted by the object's weight is the same as the upward force of the air resistance. This causes no acceleration, as there is no resultant force on the falling object, causing it to not accelerate any further. So, coming back to our movie example, the increased area of the dinghy allowed Indiana Jones to have a greater air resistance and allowed him to have lower terminal velocity, helping him to land at a lower speed. In conclusion, we can say the dinghy saved the day.